All right, gang, so today we're going to start our unit on the living Earth. The living Earth is basically about the ways that our Earth adapts to us and that we adapt to the Earth. Basically, it doesn't adapt to us. We force it to change. So in looking at this, we're going to be, you can see there, we're going to look at the physical and ecological processes that change the Earth's surface. We're going to look at climate patterns and weather phenomena and how they affect us as humans and how we adapt to that. We're also going to describe how humans influence our environment and how we are influenced by that. And we're also going to look at technology and how new technologies allow us to change our Earth and allow us to adapt to our environment and live in different environments. So in order to start this out, we've got to talk about the physical and ecological processes that shape the surface of the Earth. So basically, I want you to think about one, how are mountains made? You might remember this from earth science, you might remember this from other classes, but think about how mountains are made. And after you think about how mountains are made, I want you to think now about how valleys are made. So how are those valleys going to be made as compared to how those mountains are made, and what are the two differences there? Okay? Well, basically there are many different ways or many physical and ecological processes that build or create or shape the surface of the Earth. And those can be broken down into two categories. And the way I want you to think about this is, how do you change your appearance? I can change my appearance as simply as taking off my glasses, shaving my beard, getting piercings. Those changes take place on the outside. Okay? Or if I want to gain a lot of weight, I'm going to eat a lot of food. I'm going to try to lose weight, maybe put on muscle. I'm going to go to the gym and work out and get all big and buff and strong. Okay? But all of those things, the changes take place either inside my body or outside. The two types of changes are called physical changes. Okay, and those occur on the inside. That's eating a lot of food so I get big, or working out so I get bigger and strong. Or ecological changes are changes that occur from the outside. And those changes are me cutting my hair or shaving my beard. Those are all different ways that the Earth's surface is shaped. Okay? Well, first of all, let's talk about the physical or ways that the Earth is shaped from the inside. First of all, let's understand that the structure of the Earth is a little bit like a pizza. I'm going to explain how this is related to like a pizza. Okay? So the Earth, first of all, is not solid. Just like your pizza is not solid, the Earth is certainly not solid. The Earth has lots or several different layers. The land we're walking on is called the lithosphere, and it's floating on liquid rock that is called the asthenosphere. Okay? And the way I want you to think about this is that the land that we're walking on are the toppings of the pizza. The asthenosphere, which is going to be this thin area right here, okay, this liquid rock area is sort of like the cheese on your pizza, and then the area underneath, the mantle, which is also liquid hot rock, but this mantle is sort of like the pizza sauce, okay? And the very crust, or the middle of the pizza, the very bottom, is this right here. It's that solid core, okay? So that's how I want you to think about this. And the continents are at the very top, and those continents can shift around, and they can move around. Sort of like floats on a pool. When the wind blows on a pool, the continents can float around, and they can bump on each other, okay? So that's the basic idea of the things that I want you to get, that the Earth's surface is either kind of like a pizza, or can be compared to a pizza, or the Earth's surface are like floats on a pool. So the theory of these continents moving around is called continental drift theory. It was developed, first of all, in 1912 by a guy named Alfred Wegener, developed continental drift theory. And in his continental drift theory, he said that there was once a supercontinent, okay, named Pangaea. However, that supercontinent began to break apart and shift into different tectonic plates. So as time moved on, those plates got further and further apart, and those continents got further and further apart. And that spreading, or that moving apart, is helped by the seafloor. And that seafloor has been spreading. So the seafloor is what encourages those continents to move apart, and the seafloor has been spreading. Okay, a little bit more about plate tectonics. As you can see here, we've got a map with all of the different tectonic plates on there. So the Earth's surface is made up of these giant moving plates of rock, and they're called tectonic plates. And those tectonic plates and the movement of those tectonic plates are what cause earthquakes to shake, and they're what cause volcanoes to erupt. What I want you to get into your mind is this. So earthquakes happen. Well, let's hold on to that thought for just a second. By the way, find the plate that we're located on, find the plate that makes up most of the Pacific Ocean, and find the plate, it's kind of easy, it's called the Pacific Plate. And then take a look, and what do you think the projection of that map is? Okay, earthquakes are when or happen when two tectonic plates come together and they grind. Okay? The image I want you to get is when you're at homecoming or at a school dance and you got people dancing. Okay? Nothing happens when two people are dancing out on their own on the dance floor, right? So you're dancing, you're dancing, you're dancing. Only things happen when those two people get together and they start rubbing up on each other. Now, nobody dances like this anymore. Everybody dances like this and grinds up on one another. So earthquakes happen when those tectonic plates meet and grind upon one another like this. That's when all the action happens, is when tectonic plates grind together like at a homecoming dance or at a dance or at a club or something like that. A lot of earthquakes on Earth take place around something called the Ring of Fire, also known as the Pacific Rim. And I've got a map that I'll show you that in just a second. Earthquakes can cause a lot of damage if they occur in heavily populated areas. Just like if two people are dancing on their own in the middle of the floor, nothing's going to happen. Only trouble happens and only big things happen when people start grinding up on one another like that. That's when stuff happens, is when they actually meet to grind. If they're dancing like this, it doesn't really matter. If they're dancing like this, that's when things happen. Okay? Earthquakes and other seismic events are measured using the Richter scale. A seismic event is any event in which tectonic plates are moved or are shifting. Okay? So these are earthquake zones. The areas here on this map that are earthquake zones are the areas that are outlined here. They're not all outlined with the dotted lines, but you can see the little code right there that shows you there. Now, the Ring of Fire is the area that is around the Pacific Ocean right here. And you can see it along the west coast of the North America and South America. So let's talk about volcanoes. So we've got earthquakes. Now let's talk about volcanoes. Volcanoes are a vent letting off heat in the form of magma, liquid hot magma from inside the earth. And volcanoes are basically just like your pizza topping. When that pizza sauce has to come up through your cheese, that's what has to happen, okay? And that's what's happening. It's a vent. It's too hot. It's got to bubble forth. It's got to come out and go and explode. Or when you get tectonic plates grinding up against each other, you got to let off heat, and sometimes it explodes, just like at the club. Okay, they're grinding and they explode. That's a letting off of heat. Okay, the volcanoes are also found around the Pacific Rim, and that's why it's called the Ring of Fire, is because so many volcanoes exist around that area of a lot of seismic activity. Okay, volcanoes can cause a lot of destruction whether or not there are people around, and the kind of destruction that they cause is largely dependent on what's there. Now, if there are trees there, so they burn a lot. But here's my question for you, is do a lot of people live near volcanoes? Yes, is your answer. Here's why. The volcanic ash, when it burns trees, when it's released from the volcano, is very fertile. It mixes with the soil. It makes good crops. The bad side, so that's the good side. You can grow good crops. The bad side is if the volcano erupts, you're going to have a little bit of trouble living there because you can't really hang out where there's a volcano and liquid hot magma. So you're going to have to move every now and then. Okay, you can see volcanoes there. You can see them around the Ring of Fire. Those little triangles on that map illustrate that. All right, so those are the internal forces shaping the Earth. So we talked about tectonic plates and how they grind upon one another, and that grinding upon tectonic plates causes volcanoes to occur and causes earthquakes to occur as well. So let's now talk about the external forces shaping the Earth. The external forces shaping the Earth are threefold. First of all, we've got erosion. Erosion, and by the way, these are changes taking place on the outside, or ecological changes. Erosion is basically picking stuff up. Okay, the basic idea of erosion is that you are picking stuff up and you're not putting it down yet, at least not yet. So you're picking stuff up. Erosion, the technical definition of erosion, is the wearing away of the Earth's surface. So the erosion is wearing away at the Earth's surface, and there are three primary agents that we're going to talk about in wearing away at the Earth's surface. The first agent wearing away at the Earth's surface is water. Water picks stuff up, water rushes by, picks up the loose soil, and moves it. That's how water causes erosion. Wind also picks up loose debris, picks it up, throws it against a hard surface, and that causes erosion by, over time, gradually wearing away at the surface of whatever it's blowing against. And last but not leastly are ice or glaciers. Glaciers are simply big slabs of ice and snow that's accumulated over the years. So all that snow gets compacted down into glaciers. And what happens is, as more and more gets down and it gets compressed, as it presses down, it melts a little bit because it creates a lot of pressure at the very bottom. at the very bottom of that glacier, it gets melty, okay? And it starts to move. And when it moves, it creates friction, which creates even more heat, which causes more friction, but also wears away at the surface of whatever the glacier is resting on. The second external force shaping the surface of the Earth is deposition. Deposition is basically putting stuff down. If erosion picks things up, deposition's got to put it down. Deposition is technically phrased as the laying down of sediment by wind, water, or ice. Laying down of wind sediment. So basically, it's picking stuff up from one place and moving it to another. Here you can see on this river, this bank here is an example of deposition. What happens is this river is going to erode, drop things off here, pick up speed in the road on the other side, and it'll drop other sediment off on the other side. An example of a form of land created by deposition is a delta. When rivers, the Mississippi, the Amazon, or the Nile River, or any other delta river for that matter, when they enter an ocean, they have to slow down. As rivers move on, they pick up a lot of sediment. And as they pick up that sediment, they eventually have to drop it off. When they hit that ocean, everything stops. And in order to get the water into the ocean, they have to drop that sediment load. And that sediment load forms a rich, fertile soil in the shape of a triangle. Okay? And that shape of a triangle is what the Greek letter delta looked like. And that's why it's called a delta. Lastly but not least, the last way that the Earth's surface is shaped is called a flood. When there's more water than a soil can handle, you get a flood, and that's what happens. Floods happen when you get a lot of rain, usually. Floods happen in a little other time, but primarily it's when you get a lot of rain, you get a flood. Floods cause a lot of damage. If floods are the cause, what do you think the effects are? Monetary damage. Homes being torn apart because the floods are eroding. There we go, back to erosion. The floods are eroding the foundation that the houses are on. And so floods cause a lot of damage, primarily, again, when people build houses, people develop areas, that's when flooding can be a problem. Bangladesh is an area of the world that experiences a lot of problems because of flooding, because of their yearly monsoons, because a lot of people choose to live in Bangladesh at the mouth of the Brahmaputra and the Brahmaputra River, where it empties into the Bay of Bengal. All right? So here's what I want you to do, Tyler. I want you to take your notebook, or anybody else watching this if you want, and I want you to create a visual of what we talked about today. You can see the outline here, but what I want you to do is take this outline, and I want you to draw a picture for each and every portion. So you've got physical processes and ecological processes that change the shape of the Earth. I want you to draw a picture for each. Draw a picture of tectonic plates, and then draw a picture that represents earthquakes and volcanoes. Draw a picture for ecological and erosion, deposition, and floods, and then the different agents of erosion. All right, hope you guys had a great day, and I will talk to you all later. See you next time.